In the last videos, we have studied about Butterworth filters. These are Chebyshev filters, another type of filters. These are the formula necessary to solve any problem based on Chebyshev filters. Kp is equal to 20 log 1 divided by under root 1 plus epsilon square, where Kp is the passband gain and epsilon is the ripple factor. Delta P is equal to 1 minus 1 divided by under root 1 plus epsilon square. Ks is equal to 20 log delta S. From this we get the values of delta P and delta S. From this formula Kp will be given, we get the values of epsilon. After knowing these values, we have to find the selectivity factor K is equal to omega P by omega S. These both will be given in the question. Next is discrimination factor D is equal to under root 1 minus delta P whole power minus 2 minus 1 divided by delta S whole power minus 2 minus 1. Delta P and delta S will be substituted the values we obtain here. After finding the values of K and D, we have to find the order of the filter N given by cos inverse 1 by D divided by cos inverse 1 by K. This is cos hyperbolic. After getting the values of N and epsilon, we find the values of A and B. A is given by 1 by 2 into 1 plus under root 1 plus epsilon square divided by epsilon whole power 1 by n minus 1 by 2 1 plus 1 under root 1 plus epsilon square divided by epsilon whole power minus 1 by n. Similar formula for B, the only change is A is between two terms there is a minus sign, and to find B between two terms there is a plus sign. After finding the values of A and B, we have to plot a table which states sigma k and omega k. Sigma k is equal to minus a sine 2k minus 1 into pi by 2n. Omega k is equal to b cos 2k minus 1 into pi by 2n. K value ranges from 1 to n, where n is the order of the filter. Substituting the value of 1, 2 and up till n in place of k, and n keeping the n value as the order of the filter as constant, we find the value of omega k and sigma k and omega k. After obtaining all the 8 values, 4 in each table, we obtain one real part and imaginary part. Sigma k obtained is the real part and omega k is assigned with j, which becomes the imaginary part. Hence the pole becomes sk is equal to sigma k plus j omega k. The transfer function hn of s is given by kn divided by s minus s1 into s minus s2 into s minus s3 and so on up till s minus sn. After applying polynomial multiplication for the denominator, we get the quadratic equation or any higher order equation where the last term will be a constant term. That is known as b0. If n value is odd, such as 2, 4, 6, 8, etc., then the kn value becomes b0, which is obtained in the higher order equation. If n is a even number, then kn is given by b0 divided by under root 1 plus epsilon square. After knowing the basic formulas for Chebyshev filters, let us solve a numerical step by step. The question given is design a Chebyshev analog low pass filter that has minus 3 dB cutoff frequency of 100 radian per second, stop band attenuation 25 dB for all radian frequency past 250 radian per second. Find the transfer function of this filter. First we have to calculate as we know that the frequencies given in the question are very large, hence we normalize this filter. Normalized filter is a filter that has omega p as 1 radian per second. Hence we have to find omega s, which is given by omega s is equal to omega s dash by omega u. Substituting omega s dash as 250 radian per second and omega u as 100 radian per second, we get 2.5 radian per second. This is omega s. From normalized filter we get omega p as 1 radian per second. First we find passband gain Kp, which is given by 20 log 1 divided by under root 1 plus epsilon square. Kp will be given in the question and we find the epsilon value from this numerical. Kp is equal to 20 log 1 divided by under root 1 plus epsilon square. Kp is minus 3 dB. 20 log 1 divided by under root 1 plus epsilon square. Sending 20 to the denominator, we get 0.15 log, and this remains here. Log to the base 10, therefore 10 raised to minus 0.15 is 0.5012, and 1 divided by under root 1 plus epsilon square. Squaring on both sides, we this square root and square gets cancelled. 0.5012 is equal to 1 divided by 1 plus epsilon square. Hence we get the epsilon value as 0.99762. After getting the epsilon value, we find delta p, which is passband ripple. Passband ripple is given by 1 minus 1 by under root 1 plus epsilon square. Substituting the value of epsilon obtained previously, we get delta p is equal to 0.29205. We know that Ks is equal to minus 25 dB. We have to find delta S. We have the formula Ks is equal to 20 log delta S. From this we get the values of delta S. Delta S is 0.0562. After finding the values of epsilon, delta P and delta S, we have to find selectivity factor K, discrimination factor D, and order of the filter N. To find K, we have the formula omega P divided by omega S is equal to 1 divided by 2.5, which is K is equal to 0.4. Discrimination factor D is given by 1 minus delta P whole power minus 2 minus 1 divided by delta S whole power minus 2 minus 1. Substituting the values of delta P and delta S, we get D is equal to 0.05615. After getting the values of K and D, we have to find N. Cos inverse 1 by D divided by cos inverse 1 by K. The cos used here is hyperbolic. In calculator, there is a button hyperbolic h by p. After pressing that, we get 5 hyperbolic trigonometric functions. Clicking 5, we get D value is 0.05615. Cos inverse 1 divided by 0.05615, we get 3.75. Similarly, for cos inverse 1 by K, K value is 0.4. Cos inverse 1 by 4 is 1.566. Dividing both the answers we get N is equal to 2.2798. Rounding off it to the next integer, we get N is equal to 3. After finding the value of K, D and N, we have to substitute these values to find A and B. A is equal to 1 by 2 into 1 plus under root 1 plus epsilon square divided by epsilon whole power 1 by n minus 1 by 2 into 1 plus under root 1 plus epsilon square divided by epsilon whole power minus 1 by n. Substituting the values of epsilon and n in this formula, we get the value of A as A is equal to 0.298618 and similarly B is equal to 1.04363. The n value obtained is 3, hence we have to plot the table for K value as 1, 2 and 3. Substituting K as 1, 2 and 3 and n value keeping as 3 constantly, we get the value of sigma K for all 3 values and omega K for all 3 values. After obtaining the values of sigma K and omega K, S1 will be minus 0.14931 plus J into 0.90381. S2 will be minus 0.29862 plus 0. S3 will be minus 0.14931 minus J 0.90381. Substituting these S1, S2, S3 in the formula, transfer function S3 of S is equal to Kn divided by S minus S1 into S minus S2 into S minus S3. From the table, S1 is minus 0.14931 plus J 0.90381. Similarly, S2 and S3 are substituted. After applying polynomial multiplication for the denominator, we obtain S cube plus 0.59724 S square plus 0.928 S plus 0.2505943. The constant term obtained is B0. Since the n is odd, the numerator Kn is equal to B0. Hence the final transfer function becomes 0.250593 divided by S cube plus 0.59724 S square plus 0.928 S plus 0.2505943. This is the transfer function obtained for normalized filter. Since the given question the frequencies were very higher frequencies, we have normalized the filter and taken as omega p is equal to 1. Hence we have to denormalize the filter to obtain the original filter. We divide S by 100 radian per second since omega p was given as 100 radian per second. In the place of S, substitute S by 100 and then we obtain the original filter as 250594.3 divided by s cube plus 59.72404 s square plus 9283.4 s plus 2505943.3. This is the transfer function for the filter given in the question. For this transfer function, we have to substitute and evaluate the transfer function at 100 radian per second. Hence, the transfer function h3 of j omega, when omega is equal to 100 radian per second, is 250594.3 divided by, in place of s, substitute 100j cube, and here 100j square and 100j. After opening the brackets, we get 250594.3 divided by minus j 10 power 6, 59.72404 100 square plus 92.8j minus 250594.343. To find the magnitude for the denominator, a plus jb, the formula is under root a square plus b square. Hence, 20 log of this transfer function is 250594.3 divided by under root a square plus b square. The obtained answer is minus 2.76 dB, for which the approximate value is minus 3 dB. Hence, 20 log h of j omega is minus 3 dB.